Good morning, everyone, or good afternoon, depending on where you're attending this webinar from. First and foremost, I would like to thank you all for taking time out from your schedules to attend this webinar. Welcome again. Today's topic, Migration to IEC 61850 Edition 2, Approaches as well as Best Practices. This webinar would detail the key requirements in planning and executing IEC 61850 Edition 1 to Edition 2 migration for customer products and services. The talk aims at covering the major differences between Edition 1 and Edition 2 of the standard, as well as the key functional areas of Edition 2 that a migration needs to address. This session also would cover the additional test cases that need to be implemented, as well as the best practices to be followed. This talk is based on our extensive experience with leading global protection and automation OEMs, where Kalkitech work as preferred R&D partner. A brief on Kalkitech. Kalkitech has long been an advocate of open standards and standards-based communication to facilitate interoperability in the true sense. Our solutions enable customers implement mission-critical applications across the smart grid solution spectrum, ranging from substation automation to wide area monitoring, distribution automation to advanced metering infrastructure. To introduce myself, I'm Gautam, and I take care of Europe and Latin America business for Kalkitech AEC offerings. AEC being the US-based company acquired by Kalkitech in 2014-15. A few points to keep in mind before we start off. Since we have a large number of participants, this is a listen-only webinar. However, to facilitate clearing of your doubts or queries that may arise during the course of the webinar, you can kindly send us your questions by typing in the window provided during the talk itself. We would try to address most of your questions here or come back to you individually in case we run out of time. The presented talk would be for 40 to 45 minutes, followed by questions selected at random. I would now like to introduce you to the panelist for today's webinar, Mr. Tony, AVP Services Group. Tony handles business development for the services division and has 16 years of industry experience designing and implementing communication solutions for the energy industry. His core areas of expertise include communication protocols and enabling utilities as well as OEMs in migrating to standards-based communication. He has organized multiple training programs for customers worldwide in protocols including IEC 61850, DNP3, IEC 60870-5, etc. Tony has been actively involved in various protocol implementation projects and is responsible for managing our key service accounts. The talk would be greatly influenced by the experience Tony has gained from the various projects we have completed and currently executing relating to 61850 implementation services or migrating customer products and offerings to Edition 2. Without any further ado, I would now pass controls to Tony, who would take it forward from here. Over to you, Tony.
Thank you, Gautam. Thanks a lot for that great introduction, and welcome all. So today we can have a brief session. Migration to IEC 61850 Edition 2. Why it is required, what are the best practices, and what are the implementation challenges. So this is what I plan to cover during this session. So we'll go through the 61850 current developments, including the Edition 2 updates that are being released. And we can go through a comparison or selection of the major areas that got impacted because of this new edition being released. So that will be primarily from an implementation perspective. We'll analyze the impact. And as you know, confirmation or a conformance test That is another area which requires key focus in your migration process. So there are basically a lot of changes in the conformance test procedure, and we can briefly go through all those impacted test cases and additional test cases that has been introduced into the testing scenario there. And as Gautam was mentioning, we'll take maximum 40-45 minutes, and after that we can go into the questions. So IEC 61850 standard. I believe that all of you are well aware about the 61850 edition 1 standards. It was first published in 2004, and since then IEC 61850 has been adopted as a global standard for substation automation. It seamlessly integrates electrical equipments to control system primarily in the power utilities. Um, but this edition 1, it has encountered some gaps and some inconsistencies. And as you know, IEC is a continuously evolving standard committee, and IEC 61850 also continues to evolve. So 61850 edition 2 was released in 2011, and 61850 is being specified as a protocol not within substation, but something that has scope beyond substation now. So that's a major change what you see when you compare this edition 1 and edition 2, because originally when 61850 was introduced, it was primarily intended for the communication within your substation. All the services, all the functionalities were intended more of a intra substation communication. But in edition 2, you will see a major change in the concept there. 61850 is no more a protocol within the substation, it's something going beyond your substation. So in addition to, you will see a lot of functionalities and features that are being added there. And primarily you will see a lot of modifications in the file formats that are used in the IED configuration, and as well as new introduction of services there in addition to. So this is the current status of edition 2 specification. The latest one that was released is the IEC 61850-6 edition 2.1. So 2.1 is basically an amendment to edition 2. So that's called as 2.1. It's not called as edition 3 or anything. Instead, since it's an amendment, it's called as edition 2.1. So in 61850-6, that is the configuration file formats, functional extensions are added based on the changes in parts of 61850 specification, especially 7-2 and 7-3. So we had the 7-2 and 7-3 that got upgraded to edition 2, and all the changes based on those updates were incorporated into this dash 6, and that's there in 61850-6 edition 2.1. It primarily includes the extensions concerning the engineering process, especially for configuration data exchange between system configuration tools. And also it includes a lot of clarifications and corrections. That's about IEC 61850-6. And similarly, we have amendments that are getting ready for 7-2, 7-3, and 9-2. So 7-2 and 7-3 are expected to be released by August of 2019, and the 9-2 release is expected by end of this year, that's November 2019. So that's the current status of IEC 61850 editions. And I was telling like the major change when compared between edition 1 and edition 2. Yes, of course, the most visible change is on the configuration file formats. So as I was telling, this SEL or the substation configuration language, whatever is there in edition 1, that is more specific towards your substation configuration. And as 61850 is evolving into a protocol that is exceeding or that is going out of your substation, extending your substation functionalities. So it cannot be called as substation configuration description language anymore. Instead, the SEL has been rightly expanded as system configuration description language now. So that is in nutshell the major modification between edition 1 and edition 2, and all those functional changes in SEL can be attributed to this change in perspective. And as you know, in a SEL file, we'll be having multiple sections. there will be a substation section, there will be a communication section, and there will be a device section where all the details of the IEDs and the logical nodes and all those things will be there. So broadly, we can divide the SEL file into these three sections: the communication section, the SEL section, the substation section, and the IED section. And now the thing is like, except the substation section, all other sections and definitions can be used for any application domain. That means the IED section and the communication section in your SEL, that's not really limited to the substation. Instead, it can be used for any application domain, and that can be your hydropower, it can be your DER, wind power quality, power PQ power quality, or your SCADA system. So that's a major change in perspective in addition to. So addition 2 or IEC 61850.6, the SCL file, I've told that the addition 2 introduced a few new configuration files. So they are primarily the IAD file and the SCD file. So IAD stands for the instantiated IAD description, and SCD, it represents the system exchange description file. We'll come to know what exactly are the functionalities of these file types. But the point you have to keep in mind is like, these two files, they have introduced two new schemas also for these files. That means if you have a application or a device that is getting migrated into edition 2, you should have the support for these new file types and of course the new schemas. And edition 2, basically it's considered as a backward compatible extension, which means a edition 2 device always shall support edition 1 schema. So in your edition 2 application, you have to have support for interpreting the edition 1 schema as well as the edition 2 schema. So that's something which you have to keep in mind while defining your product functionalities. And as you know, many of these features are not really affecting a device per se. Instead, all these SCL extension has got more impact on your configuration tool, the ICT. So in order to have a conformance to this addition to your ICT has to be upgraded with support for this new file types, the IAD and SCD. Now, to see what is the impact of this or what exactly is the purpose of this IAD and SCD file, let us see the general uh, configuration workflow. Um, so I was telling this IEC 61850 defines multiple types of configuration files, all coming under your SCL file, system description files. The substation configuration language. So here you can see there are 6 different types of files. The SSD stands for the system specification description. The IED capability description is defined as an ICD file. Now we have a system configuration description file, what is abbreviated as SCD file. Then we have the CAD file, which is of course the configured IED description file. And then we have the new files, the SCD and IAD. Now, the thing is like, all these configuration files, all these variants of the SCL files, they are having the same common intention. That is exchanging the configuration information between your applications and the IED that you are configuring. So all these files basically do the same end objective: getting the configuration correctly downloaded into your IED so that your IED is working as per the design. So you'll be wondering why do we require so much of configuration files? So you have a IED configuration tool, and and IED configuration tool is generating something called a CAD, the configured IED description, which is downloaded into your IED. So that's the straightforward programming or engineering concept. You have a IED configuration tool, which is provided by your IED vendor, and that is normally a graphical interface based tool where you can do a lot of configuration specific to your IED, save that configuration and download it into your device. And that exactly is being done by your CID file. But why do we really require the other tools? So the 61850 workflow, it specifies about three different tools. The IED configuration tool, which is actually a tool that is provided by the IED vendor. So there will be specific IED configuration tools specific to each of the vendor, and probably for different makes of the devices given by the same vendor, you will see different IED configuration tools. That's quite normal. But here, um, one of the major feature of IEC 61850 is interoperability. Interoperability allows, or it gives a provision of seamless integration of information exchange between devices that are provided by different vendors. So here you can see there is a system design or system specification design tool, and then there is a system configuration tool. So these two tools are actually independent of the vendor. They can be provided by the vendor itself, but the thing is like these tools should have open interfaces by which it should be able to ingest different SEL files generated by different IED configuration tools. So I was telling this, the primary purpose of your IED configuration tool is to configure your device. So what are the typical configurations that go into a IED? The most simplest example is the IP address. So once you have a device, in order to commission it in the site, the first thing you have to do is assign a IP address. So that is typically a function done by your configuration tool. And if you have multiple IEDs, probably you can use the same tool, provided all those devices are from the same vendor that is supported by your IED configuration tool. Then you can use the same tool to generate multiple CID info, which will get downloaded into individual IEDs. But now the problem is like, so the one setting that goes is the IP address. Additionally, there will be a lot of settings specific to the IED functionality that has to go into the device during the configuration, because that has got a dependency on the project and the site. So that's primarily the instantiation of the IED. You have to have individual settings being, or you need to load individual settings into each IED. So that is typically taken care by your IED configuration tool. Uh, but the thing is like 62850 IEDs are not individual devices, or they don't work in silos. They have the capability of exchanging information between themselves. So Goose is one classical example of this information exchange between IEDs. That's a peer-to-peer communication. Now, one of the requirement is like in a project, each IED has to have a bare minimum information of the other IEDs that are there in the network who are capable of sending information to it. And also it has to have a valid configuration of which all information it should subscribe to. So this constitute the data mapping philosophy. So data mapping is that mechanism by which you configure which all data goes from a originator IED all the way to the destination IED. So that's the data mapping configuration. So in a project, there will be multiple data mappings there, and there will be having I mean, this data mapping has got a big dependency on other IEDs, which means there should be a single configuration file which contains all the IED specific properties, as well as all the data mappings, as well as all the communication instantiations. So that is being done by your system specification tool and the system configuration tool. Now, another thing what you have to keep in mind is that there is something called a CID, or a configured IED description file, which is more of a template. So for a particular model of a IED, there will be a single ICD file that will be typically generated by the IED configuration tool. So this will be either generated by the system integrator or the vendor himself. But the assumption is that there will be a ICD file that is generic in nature, which does not have any project specific information, but primarily the capabilities of that IED described in this ICD file. And that will be generated by your IED configuration tool. And typically we have a bottom up. No, we have, I mean, if you take the case of this top down approach, and the design starts with the system specification design, where a system engineer will define the first thing will be the single line diagram that represents the substation, and also he may add details about the primary equipments that are there connected to the SLD, and also the functionalities that are performed by each of the functional equipment in the SLD. So that does not have any dependency on the IED vendor or the IED that is being used for realizing that function. So it's a generic file, and that's called the SSD file, the system specification description file that's generated by your system design or the system specification tool. Now, we have another tool called the system configuration tool. Basically, it has got the capability of ingesting your SSD file and multiple ICD files representing each of the type of device that is there in your configuration. So one thing what you have to remember about the ICD file is like inside the ICD file there will not be any names at all. Instead, all of the data model will be mentioned as data templates, and it will be a responsibility of the system configuration tool to instantiate those templates and give them appropriate names which represents the actual IDs that are being planned to be deployed in that configuration. So the system configuration tool essentially ingests the SSD file and the ICD file. It does the instantiations, and also it does all the mappings or binding of each of the IED functionality to the functionality specific or the specific functionality that is defined in your SSD file. So it does this, and output of that configuration will be something called the SCD file. So that is the master configuration file, which contains all your substation model information, as well as the IED data models, as well as the data mapping or the data flow between these IEDs and the communication parameters that are required for the IED. So this SCD is your master configuration file. Now, once the SCD is generated, that acts as a master file, and it's possible that multiple IED configuration tool, given that in a particular project, if you have IEDs provided by multiple vendors, you can load the same SCD file into these multiple tools, and the tools will extract the configuration required for each of the device that is being connected to that tool. It will extract that information, and that will be downloaded into the IED. So this is the general configuration workflow. But the thing is, like I mentioned, this ICD being a generic tool, and most of the cases the ICDs will be predefined. But as part of the project, the IED configuration tool may make some modifications in the IED's data model. It may enable one of the logical node or one of the function that was previously disabled. So always the IED configuration tool has got that flexibility, and it may do some modifications, and that will get downloaded into the IED. But the problem is that all those additions will get blocked, or that will not travel all the way back to your system configuration tool. Now, SCD being your master configuration file will not be having that update, because the IED configuration tool is not supposed to edit any of the SCD information. Instead, it has to extract the relevant information and create the ICD. So that was one issue, or that was one shortcoming in edition 1, and there were different mechanisms used by different vendors. And in edition 2.1 or in edition 2, IEC standardized or IEC provided a standard mechanism of addressing this issue, and that is called the IID file. So if at all IED configuration tool makes some modification to the data model, it will not make any modification to the existing data flow descriptions there in the SCD. Instead, it may add some additional data model, and that information can be given back to the system configuration tool as a IID. So here the advantage is that if it was given as an ICD, then the system configuration tool has to start from scratch, start the initiation and do all the mapping. Instead, in the IID, all the instantiations that were done by the system configuration tool are already present, and all the data flow mapping that's done by the system configuration tool is already present. So the system configuration tool has to just accept that IID file, and it can replace the relevant part of that SCD file with this new IID information, so that it has got a concurrent configuration that's running in the IED. and that will be given back to the IED configuration tool, and the IED configuration tool will generate the CAD info, and that will be downloaded to the IED. So this is the new workflow once you have the IID in picture. So that's about the IID. Now let us see what is SED, the System Exchange Description. And I was telling this 61850 no more is limited to a single substation, and it's possible that you can have multiple substations that are exchanging information. Also, it's possible that we can have multiple defined boundaries within the substation, uh, which are managed and maintained by separate SaaS functionality or SaaS projects. So in that case, we have the concept of this project where some of the IEDs in one substation is owned by one particular project, and there are some there is another project which owns some other IEDs. So these projects can be referring to two substations itself. Now, if there is a requirement of data exchange between these two substations, each of the SCT, the system configuration tool, should have some bare minimum information about the sources of data that are available in the source or in the other project. That means there should be some sharing of information between the system configuration tools. And it's never advised to share the entire SCD because that will contain a lot of information which are not really relevant for the receiving program. So for that, we have the concept of this SCD file, which is a extracted information from your SCD file, which contains those information, only those information that are required by the other project in order to do the configuration. So that is the SED file. So that is a subset of your SCD file, the master configuration file. So the SED or the system exchange description file is a subset of your substation configuration description file. And here we have sufficient mechanisms being designed or being the guidelines given by IEC to ensure that sufficient user rights are imposed, which ensure that the other project is not making any unintended change in your configuration file. So we have the concept of user rights. So before extracting the SCD, the system configuration tool will set the sufficient user rights to the SCD, and that will be given to the other project. And the other project may use it for its configuration, for its internal mapping based on the user right. It may modify the SCD so that additional data mappings from the other substation will be mapped here. Ultimately, the new SCD will be given back to the original system configuration tool. So this contains all the required information about the other project, and that will be ingested by the system configuration tool, and that will be updated into the SCD. So that's about the configuration workflow, and that's how the IID and SCD are being inserted within the regular configuration workflow. Sorry. And this is another diagram which shows the configuration mapping. I was telling the ICD is basically a template file. It does not have any instantiated information. That means it can be a pre-configured template file which defines the capabilities of the IED. And if you have two IEDs of the same type in your project, the system configuration basically uses the ICD file, and it will generate two separate instances of that ICD as IED1 and IED2 in the SCD file. Now, this SCD file can be loaded into a IED configuration tool where the IED configuration tool is currently configuring IED number 2. So IED configuration tool can make some modifications into the data model of IED2 alone, not into the IED1, and that can be updated back to the system configuration tool via a IED file representing the IED2 IED. So that's number 3 mentioned here, which goes back to the this is the IED2 of, this is the IED file of IED2, which goes back to your system configuration. So that covers the major area of this edition 2 migration, that's handling the new file types and file syntax. Now, another area where there is an impact with the edition 2 is the Goose. So all of you will be knowing what is a Goose message. Goose, it essentially provides a fast and effective exchange of information, primarily the time critical information between IEDs. So without a client in the network, two servers can communicate between each other. That's a peer-to-peer communication. That's not very popular among the protocols. So Goose provides that information, that mechanism by which you can exchange information between the servers. And as you know, Goose are high-speed messages which are primarily multicast in nature, which means the device which is sending the Goose message, it never know who all are subscribing or who all are reading that information. So it's an unconfirmed service, and it does not know who all are receiving that information. Similarly, so it's a responsibility of the configurator to correctly specify to each IED which all Goose messages it should subscribe to, because Goose is something like a multicast. So in the network, you will see all the Goose messages that are being published by all the devices. So there should be an effective mechanism by which the configuration tells the device you should subscribe to so and so Goose messages. You should extract so and so information out of those subscribed Goose messages and use it for your internal use. So that has to be a part of the configuration tool, and that specifies the majority of the data flow mapping in your substation configuration tool. And same is the case in the sampled value streams. There also we have to have a similar mapping. Now the problem with edition 1 was like, in edition 1 there was a mapping what we call the input external reference input mapping, where the substation configuration tool will tell each of the IED that you will be getting so and so data from an external device. So that is done by adding a separate section in the SEL file called the input section, where these external references are updated for each of the IED. Now, the one of the shortcoming was like, this information alone is not sufficient to establish a successful Goose subscription. For that, the subscribing device has to know whether it's a Goose message or it's a sampled value message, and if it is a Goose message, what is the control block reference or the reference of the control block that is generating those Goose messages. So without that information, it cannot set up a successful subscription. And in edition 1 specification, this control block reference and the source type was not there. But in edition 2, they have changed the configuration strategy, and within the input section defined for all the external inputs in each IED, there is a external reference data that is what is there even in edition one as well, which includes the IED name, the LN instance, and the DODA attribute, that object or that attribute reference. Now, additionally, this section defines a service. So in addition to, we have this additional section which defines a service that is used for this input update. So that specifies whether it's a Goose or a report or a sampled value or a poll is responsible for that external input update. Now, other than this service type, it also provides the source control block. So with the source control block and the data attribute data reference, the IED can set up necessary subscription services to receive the external input. And also optional mapping for the internal address is also provided in the SCT. Now, let us see an example of how this configuration is done in a substation configuration tool. So here I have taken a screenshot from SEL Manager, which is a tool generated by Calcutta KSE. So that is a full-fledged configuration tool which can take the role of a SSD as well as a SCT. I mean, your substation description file as well as your system description file as well as your system configuration tool. So it has got the capability of ingesting all the ICD files, SCD files, SSD files, SCD files, all those files, and it can generate the SCDs, ICDs, IADs, and all the SCL files specified by IEC 61850. So in this example, you can see how we specify a particular input. So this is my source data. So I am telling my device that you have to subscribe this data that is coming from an external source. You have to subscribe to that, and this control block is responsible in generating that. So this is a Goose control block. So it says that you have to subscribe for the Goose message that is being generated by this Goose control block, and out of that Goose message, you subscribe for this data. And once you save it as a XML file in the SCT, that particular column or that particular box will add this particular line into your configuration file. So it added a section called inputs. Out of that, only one entry is made, but in the actual configuration file, you will see multiple entries which represent individual data or data attribute that is coming from external device. So here we have only one entry which says we have an external device called publisher, which is having a LD. I mean, L device one is the name, and it has got a fully qualified data attribute that is being generated as part of your Goose control block, GCB1, and you have to subscribe for that. So the service type we have to use is Goose. So this much information will be included in your SCL file. That is the file generated by SCT. So this unambiguously or without any confusion give sufficient information to your IED configuration tool to set up necessary subscription services in your device. And that was about the Goose mapping. And another area of importance is the routable Goose. So IEC 61850 edition 2.1 standard. I mean, in the original edition one, we only had the Goose messages which were living only within the substation. That means a Goose publisher cannot send a Goose message that can live across a router. The router will be something like a termination point for that. It will not get routed out. So that was one of the limitation of the Goose message. But as and when we have multiple substations that are taking part in synchronized control algorithms, we have to have some information that is being exchanged in a real-time manner between substations. And that is provided by a new service called the Argus. Argus is actually defined in your IEC 61850-90-5. That is your TR, technical requirement. So Argus is basically the same Goose message running on top of here, or the same Goose message that is being added as payload into a UDP packet, so that the UDP has got the sufficient information which will take it all the way to the subscriber. So this UDP message can travel across the routers and it can reach the destination, and that can be used for some useful calculation in the destination, and that can send back a response. So in this way, we can have synchronized algorithms between substations via Arcus. Now let us see how this is being addressed in IEC 61850. So we have a technical report TR IEC 61850-90-5, which extends the application of Goose from LAN to WAN. And a few points that you have to keep in mind when you start implementing the Argus is not just a IP UDP packet. Basically, it allows the Goose to be multicasted over IP network using a protocol called IGMP-v3. So what is this IGMP-v3? IGMP extends the capabilities of the protocol by allowing source filtering, which means that the routers are informed of the sources of the traffic. That means you can add some level of predictability into the network delays that are being offered by your network, because we have predefined routes that are already known for the routers, and they only always take this same route for the delivery. And Argus messages are routed over layer 3 routers with UDP IP headers. And as you know, Goose is a critical information which is used for interlocking, and the TR 62950-90-5, it specifies a lot of security mechanisms for that are to be taken care while you are injecting Goose messages into your WAN. From a implementation perspective or from a data model perspective, we have a RG control block, which is being used for controlling the routable Goose state information being added into the model. Similarly, I was telling these Goose messages as well as the Argus messages are used for time critical information. So even in the UDP domain also, we have some sort of priority tagging, the same way as we had this VLAN priority in the case of regular Goose. In Argus, we have this priority tagging at routers, which provides high speed quality of service for the Goose messages that are transferred across your UDP network. So that completes the Goose Argus part. Now let us see. I was telling like compared to edition 1, edition 2 contains a lot of new data models and a lot of new common data classes to build those new data models. So this gives a flexibility of modeling some of the information that were not possible to be modeled in an interoperable way in edition 1. So people used to depend a lot on GGIOs and all for modeling some information where you never had the predefined logical nodes. But here with the addition of new CDCs and new logical nodes, it's possible that you can add or you can model your system in a better way. So here I have a list of all those common data classes that are being added in addition to. You can just go through the list. Yeah, so we have two status information that's being added. And for the control also, we have two CDCs that are being added. And for status setting, we have 1, 2, 3, 4, 5, 5 different CDCs. And for analog setting, we have a CSG CDC that's being added in addition to. So from an implementation perspective, you have to make sure that if you are supporting or if you are subscribing any of the information from these new CDCs or new logical nodes, you should have the ability to understand them. And similarly, we have a few logical nodes also being added in addition to. So we have system logical nodes like LGOS, LSUs, LTRAC, LTM, LTMS. These are new special logical nodes that represents new functionalities. And the LGOS, LSUs, LTRAC, these logical nodes are actually defined in IEC 61850 edition, 61857-2. So the regular practice is like all those logical nodes will be defined in 7-3, 7-4. But here we can see a deviation from the general practice. So because of their linkage with the functionality, that I believe that's the reason there. And also we have this automatic control logical node, function node. So that's a new group altogether. Then we have the generic reference, interfacing and archiving. These are new logical nodes that are being added by 61850 edition 2. Yeah, the list is still there. We have new measurement loads. We have new measurement logical nodes, protection related functions, sensoring and monitoring, transfer sensors, power equipment. So this gives the list of all the new logical nodes that's being added by edition 2. So the naturally is like the data model library of 61850 has been enriched by the addition of or by the new edition 2 release. Now, coming to the functionality perspective, we have a new service that's being added. That is called tracking service. So that's a completely new service in addition to, and from an implementation perspective, you have to make sure that you are enabling support for that tracking services. So basically, we have two category of tracking services. One is for the MMS communication, and the other one is for the PubSub communication. So let us take the case of PubSub communication. So we have Goose publisher, we have a Goose subscriber. The Goose publisher is publishing a Goose message, and Goose, as you know, it's a continuous retransmitted message which are always injected out by the publisher, and there is no way the publisher can know whether the subscriber has successfully received it or not. So that's about Goose. And a Goose subscriber which is configured to subscribe that Goose will be having necessary configuration information there. And once it starts up and once it starts seeing the Goose messages in the network, it will subscribe. It will start to subscribe those Goose messages, and it will use that information. But the problem is like there was no mechanism by which we can monitor a running subscriber. There is no data that is being modeled or exposed so that we can monitor from a client, which gives us a feedback about the healthiness of that subscription service. So we have this Goose control block, but whether is it really subscribing in Goose messages or not? And that is one major troubleshooting issue for the engineers who are working at the field. Now, in addition to this tracking service is introduced specifically for this purpose. So this gives a supervision functionality within your device, so that an external person can supervise the functionality of your device, whether it is successfully subscribing to the Goose messages or whether it is successfully subscribing to the sampled value messages that are already configured in your device. So this is something like a new logical node which has got a set of status information, and by reading that status information, an external person or external client can distinguish between a state where the control block is not receiving anything, as well as the condition where there is a wrong configuration which is inhibiting the subscriber from receiving the correct Goose message. That means there can be a configuration mismatch between the publisher and the subscriber, or the configuration revision of the publisher might have increased, which was not updated in the subscriber. So these are typical configuration issues. So this LGOs and LSEs, they provide new set of logical nodes corresponding to each Goose control block and sampled value control block, which will give details about whether the subscription functionality is working correctly or not. And as it's pretty evident that this gives effective troubleshooting capabilities to the technical engineer there. So that's about the pub sub function. Similar to that, we have something called the LTRK. LTRK logical node allows tracking of all the MMS based communication services as well as the response. That means the LTRK, like there will not be multiple instances of that logical node. Instead, there will be only one instance of that logical node, and there will be multiple CDCs or CDC instance representing each of the MMS service. So if you have a report control block, and when an external client enable that report control block, automatically that will be updated as an entry, or there is a status field in your LTRAC logical node which says that, yeah, there was a request from so and so client at so and so time for enabling the report control block. Similarly, whenever it receives a control function, there will be another um, common tag in the device which says that, yes, I received a command from so and so client for my so and so command point with a particular value, and that was a success or a failure. So these informations give a lot of tracking options for the users. So from an implementation perspective, you have to consider these as additional functionalities, and whenever we get updates, MMS update, or whenever we start subscribing, or whenever you see there is a subscription issue, the program has to automatically update the corresponding logical node so that the tracking service is correctly implemented. And for this, we have this new additional logical nodes, LTRK CDCs. LTRK is the new logical node for tracking your MMS communication, and for sub model we have LGOs and LACs. So that's about the tracking service. Another major change, it's not actually a major change, but the thing is that even though it's a small change, there are a lot of new test cases associated with that change. That's why I have kept it as a separate slide here. So that's regarding the Goose simulation. So all of you might be knowing this. In edition 1, we had something called a simulation bit in every Goose message. So whenever the Goose is in simulation mode, that simulation bit will be set. Now in edition 2, this has been, sorry about that. In edition 1, it was test bit. It was called as test bit. In edition 2, it has been called a simulation bit. So this bit basically differentiate between a real and a simulated device. So if you have a simulated device which is publishing Goose messages that are not from a real device, the sim bit or the simulation bit of that Goose message will be set to true, which indicates that it's a simulated Goose message. Now, in order to give the flexibility for the subscribing device to ignore or accept that simulated Goose, we have a new data object called LPHD sim that is being implemented in the LPHD of the subscriber device. Now, whenever this sim bit is set to 1, that means it is enabled, or it's enabled for a simulated operation. So in that case, it will start looking for simulated Goose message. So the moment it sees a Goose message with this simulation bit set to 1, it will then ignore all the Goose messages from the real publisher. So the practical use case of this application is to test your device. So whenever there is a major configuration change, or any setting change in your IED that's already commissioned inside, you may have to see whether the configurations are correctly working by injecting a simulated condition into the relay. So for that, removing the IED from its installation and taking it to a test house is a expensive affair. Instead, you can have simulators in your network which can send out simulated Goose messages, of course, with this bit set to 1. And once the LPHD sim STR is set to true, then the device is basically known that it's subscribing to a, I mean, it's in test mode, and it will not respond to any of the real device Goose message. Instead, it will continue to work on the simulated information, and it will do the operation, but it will never energize any of the output relays. So in this way, you can completely test your functionality or the modified functionality in your device by using the simulated Goose message. So this thing is something which you have to take care when you are completing your implementation. Similarly, in the controls. So Edition 2 introduced something called a configurable hopper timeout. That's one minor change, but there is a function and there is a test case associated with that. So previously it was a fixed value, system specific fixed value. Now each of the control block can have separate configurable hopper timeout. And additional CDCs are being added in the control operation. And we have a lot of new art courses being specified by Edition 2. That means whenever a control operation is completed and the device is returning a success or failure, along with that, it has to respond this additional data, which will give a lot of information to the command originator. So this includes all these new additional classes or additional clauses like object not selected. So whenever it receives an hopper command when the object was not selected, it has to respond this art cause while giving the negative response. So you will see a lot of test cases there in the conformance test, specifically for testing each of the art cause there. So this is one area of concern, or this is something not an area of concern. This is something which you have to focus on while doing the implementation and while doing the testing. And the news is like we have this edition 1 and edition 2 testing available in UCA test houses. So even if you have a edition 1 device where it's not migrated to edition 2, you can continue to recertificate it or recertify it with respect to the edition 1 tests. But the problem is like there is a end of life for this edition 1 only certification, and that is being marked as December 31st, 2020, which means you cannot do a edition 1 testing with your new or existing device for edition 1 test cases from January 2021. As you know, edition 2 introduced a lot of new test scenarios. So for this, the test procedures are updated with additional test cases, test the conformance of the new standard. And also it has got a lot of test cases specifically to check the backward compatibility to the previous standard. So whatever is the case, after 2020, December 31st, there will be only 61850 edition 2 testing offered by UCA test houses, and you have to ensure that your implementations are updated or migrated to edition 2. Now, since we are running short of time, let's quickly go through all those new or impacted test cases that are introduced in edition 2. So basically, I have referred to all the test cases that are being followed by the test houses in this edition 2 certification test, and try to come up with a list of those specific test cases which get affected. So it's not an exhaustive list, I'll say. These are some of the major test cases that require some rework from an implementer to make sure that it's passing the new test. So service tracking, it's a new service. Definitely there are new test cases related to that. LGOS, LSV, CellTrack, LTRK. So there are new test cases related to that. It's an optional feature, but if you're going for that, you have to be ready with the test cases, or you have to make sure implementation ready to pass those test cases. Then we have this reserve times. So that's another test that got updated in addition to testing. So for the setting group control block and for the report control block, we have this reserve times, which is basically a amount of time where that particular control block instance will be reserved for a particular client. So we have additional test case that make sure that the response of the IED is correct. Also, we have the pre-configured clients in report BRCB and URCB. We have this pre-configured clients. So we have additional test case which make sure that your IED is only allowing the pre-configured clients if it is configured so. And there are updated tests for verifying the buffer overflow condition in your report control block. Then the next one is the test for verifying the reserve times, the same as SGCB, the setting group control block. Similarly, we have the report control block also that has got the reserve times. Then I was telling about the simulation bit. So there are multiple tests related to the simulation bit. How the Goose message, I mean the IED subscribing the Goose message, how it is responding to the simulation bit setting. And there are control related tests, like we have the test mode and the flag. So there are different new clarifications given in addition to which, and that results in additional tests there. And we have a new test case for verifying control authority and station level cases. That's basically the originator category. That's an additional verification added by addition to. Similarly, we have a new test verifying the additional return values, the art causes, which I was telling in the previous slide, like the locked by another client, blocked by command, etc. So we have additional test cases there to execute. So this is one big section, I'll say. So what we have seen is like we have to spend considerable time in making sure that the device is responding with all these new additional causes, art causes and responses are correct. Then similarly, we have the LTRK additional test cases, LGOS and LSV, there are additional test cases, and time sync is another area of importance. Now, time sync has been a mandatory test, and also we have this LTIM, the time management setting and time supervision, time master supervision, new logical nodes being added in 61850 addition to. So there will be additional tests associated with that. And also there are some additional test cases, or some of the existing test cases were expanded with additional clarifications or clarity on the test procedure to test the quality flag, how the quality should change when mod behavior values are changing. So as I was telling, this is not an exhaustive list of all the new test cases or the impacted test cases, but here I have tried to list down all those major test cases that got impacted, and additional major tests that you have to consider when you are migrating from edition 1 to edition 2. And that covers my agenda items.
Thank you. Thanks a lot, Tony, for the detailed and informative talk. Really wonderful. We're running short of time, so we'll quickly move on to the questions. There are a couple of questions that we have received. One is about reroutable or R Goose. Seems interesting. Can you share some real life examples of R Goose which is being used currently?
Yep, Argus is it's basically using the same functionalities provided by the 90-5 that's primarily intended for your phaser measurement data transport across different geographical locations. But Argus has been used for some interlocking. Like we are working with one of our customer in developing a HVDC controller where we have controllers at multiple ends of your HVDC lines, and they are in fact exchanging mission critical interlock information via this Argus, and that's working well and good. So that's a real life example where we got a chance to work with Argus.
Okay.
Hope that
The
answered that question.
the second question was regarding the implementation timelines. So for edition 2 implementation on from scratch on a new product, or for time for migration from an edition 1 product to an edition 2, usually what is the time frame? That is one of the questions from the participants.
Yeah. So I don't have a fixed answer or a ready answer for that. That depends on your device complexities. Depends on the technical team who is doing or who's managing your product, and of course the source code library that you are using for your implementation. So I assume that you already have a source code library which is maintained well, which gets always updated with the new releases of your standard. So with that assumption, I mean, this is my personal experience, I'll say. We got a chance to work with multiple OEM partners in helping them migrating to edition 2. So it varies from 4 weeks to 8 weeks for the modifications. So that includes the firmware modifications. That, I mean, also you have to take care about the IED configuration tool modifications, and of course the testing. So this timeline does not include the third-party test house time, but a complete implementation and in-house testing. So here in Calcitech, we have been using multiple homegrown tools, I'll say, to enable us for a speedy implementation and what you say, trouble-free testing.
Okay. Okay. Lastly, Tony, one last question. In your slides, you have shown a screenshot of an SCD file. Is it from your tool, and does it completely conform to the Edition 2 standard?
Okay, this one, right?
Yeah, I believe it's from
Yes.
this particular.
Yes, this is from SCL Manager, which is a AC Calcitech tool, and that is a comprehensive SCL tool that supports all the 6 different configuration files or different SCL files, including the IAD and SCD. And yes, it conforms completely to the Edition 2 specifications. In fact, it was this particular tool was used in the last IOP event in Brussels. Brussels, right?
Yeah,
Yep.
it was in Brussels as well as New
Okay,
Orleans.
okay.
Yeah.
So in the last IOP event, this got successfully tested with multiple vendors, and all the edition 1, edition 2 backward compatibility, all those things were tested. So this is an effective tool in managing your various SEL files.
Great. Thanks
All
a
right.
lot, Tony, once again. Thank you to all the attendees for taking time out to attend this webinar. If you've got any additional questions or queries, feel free to drop us an email at marketing@calcitech.com. We will also be sending the recording of this webinar shortly to all the attendees. Have a nice day. Thank you once again.
Thank
Bye.
you. Have a great day.